That's not a knife. That's a knife.
Well, here it is, our next pretty big project. Big in every sense of the word. Ain't she a beauty? And of course, I probably don't have to tell you all what this is, but it is a Marantz Model 2500 stereo receiver. It is a monster, and these are pretty hard to come by, so this is going to be a really exciting project. Right off the bat, you can tell it's a little bit different than some of the other receivers you see out there. First and foremost, by this really cool little oscilloscope that's on here that allows you to view several different functions such as multipath and some other things like that. So this is going to be a really exciting restoration. I've not taken this apart. It just came in, and the owner wants a complete and total restoration from the ground up done on it. It apparently plays. It apparently has never been recapped or restored, and it has been on someone else's bench in the past. Apparently it was a very reputable company, and they replaced a couple of defective transistors and a couple other small components to repair something that was damaged in it. I don't know what. But other than that, it supposedly works fine. But of course, we're not something this valuable and this rare. I'm certainly not just going to plug it in. We're going to check everything out, make sure it made the journey here okay. But if this sounds interesting to you, stay tuned, because probably for the next couple of videos out there, you're going to see me working on this wonderful old receiver. So stay tuned, and let's get this project started. Okay, let's just do a flyover here. And if you look, we have a really bad break here. The wooden case on this thing is shot. You can see it's very loose, coming apart. It came unglued. Big chunk missing over here. Broken over here. Chunks missing here. So I don't know if this is a repairable case or not. I don't have the time to go in the wood shop right now and build a new one, but this would be a really nice one to rebuild out of walnut or mahogany or cherry or something like that. But maybe the owner may have a line on a reproduction case or a good case. But we're going to take this wood off and look underneath. There should be a sub cover underneath it that's the metal, and hopefully it'll be in good shape. You can see there's quite a lot of dirt inside here, so this may be a dusty unit inside. I don't know. Like I said, I haven't taken it apart, but we're going to get the cover off and check it out and see what it looks like inside. Alright, so I have the wooden cover off, and I have all the screws off this. I have not had this apart yet, so you're going to kind of experience this along with me. One of the things I got a big kick out of when I saw this thing, and this is original, it came with it. Here is the power cord. Talk about looking like something out of your window air conditioner or your stove. Look at the size of that power cord. It's massive. So yeah, these things were built. So let's get this cover off and take a look. And there it is. Okay. So there you go. This is your inside. Here's the amplifier module. Soft start relay, speaker relay. You have your two channels, left and right, and this is a cooling tunnel actually. And essentially there's a fan in the back here. It's a 2-speed fan, and it pulls the air through here and cools the transistors. So this whole thing's made out of aluminum, and then you have the finned heat sinks that are individual with each transistor. Here's your power supply. Here's your transformer. Now, we really have to be careful powering this thing up. Toroid transformers are very good for quick pulses of very high current. They're very good at delivering current that way. But the other thing is that works to their disadvantage. If you have a problem with the soft start circuit where it doesn't work, these capacitors can cause a huge current draw on this transformer to the point where it can actually damage the windings, and that happens quite often on these bigger amplifiers like this. So the first thing you want to do anytime you get a large amplifier like this one, or the 2600, or any of the other large ones, the Pioneers like the SX 1280, 1250, 1050, all of them with these big toroids, you want to make sure your soft start circuit, your power up circuit is working properly, because when these capacitors go across the output of this transformer, they will draw a humongous surge current, and they can actually damage the windings. And these transformers are not very easy to find. So proceed with caution. Here's your power supply board, and here's your oscilloscope in here. You can see how the tuning gang is actually mounted upright instead of horizontally inside here, which is really cool. So everything kind of looks original. It doesn't seem to be, all of these caps and everything do look original. I'm not sure what components were replaced when the amplifier was serviced, but I'm sure we'll find that as we go ahead. But I'm just going to give this a big once over, check everything out, make sure everything looks decent, and then we'll try to gingerly apply some power through a dim bulb if I'm sure that everything's good on here. So stay tuned. Okay, so I've spent some time going all through all of this, making sure there's no shorts, no connectors disconnected, nothing out of the ordinary, and everything looks to be okay. Now again, this one is filthy. This one's not quite as bad as the Marantz 2238 that we had here a while back, but it's pretty bad. I mean, it's got some, you have some surface rust along here that's going to need dealt with, some dirt and corrosion here, lots and lots of crud down inside, but it's all stuff that can be cleaned. We can clean all of this. So all in all, I like them this way, and the reason being is it doesn't look like anybody has spent very much time playing around with it, you know, trying to solder things in or replace parts or anything. So it's a survivor. So here's the way this thing works. Because this one has a cooling tunnel, the cooling tunnel is wired in such a way that this fan, when the unit is drawing high current or when it's actually at high temperatures, the fan will kick on to high speed to cool the transistors down quicker. And that high speed is kind of tied in with the soft start resistor also. So what happens with these is when you first turn it on, it'll pre-charge the capacitors through a soft start resistor, which the soft start resistor on these is down in this area down here. And that resistor is right in line with the input of the transformer. It is kind of small for a soft start. Just to give you an idea, this is 200 and some watts per channel. I think it's like 200 watts per channel or 220, something like that. It's big. And it only has a 10 watt startup resistor. Just to give you an example for comparison, the SX 1050, which is 125 watts per channel, about half this, uses this great big resistor here to soft start. And that's one of the problems with these Marantzes, is that resistor will actually blow open. And when it does, as soon as the soft start relay times out and pulls in for full power, it puts a huge strain across the relay, and these caps are going to draw really excessive current from the transformer and could possibly damage it. So one of the ways that we know that this is not working properly is when you turn this on, you'll hear the fan come on at high speed. It'll come on at full speed. It'll be really loud. And then once this relay kicks in, if the capacitors are pre-charged properly and everything, this will kick in. The fan should die down, and it shouldn't stay at full speed all the time when it's, when it comes in. So we should hear the fan be loud for a second, and then it should pull this relay in, and then the fan should get quiet. Now that's going to be delayed because I actually have a dim bulb in series with this. So we're going through a dim bulb just in case there's some shorts or something, and so it'll cause the soft start to take a little bit longer than normal. So you'll hear the fan stay on for a little bit longer than normal, but eventually it'll pull in and it should quiet down. Now hopefully that's what's going to happen. If that does not happen and this thing never comes out of soft start, there may be a problem with that resistor, and then we want to really kind of check this transformer. So that's kind of the train of thought for how you first power one of these up if you don't know anything about it. So let's do it. We got the dim bulb on. We have the unit plugged in, and let's hope for the best. Hold on. Here's our bulb. This should light up real bright, and then as the capacitors charge through that resistor and through this bulb, it should dim down a little bit, at least in theory. So let's try it. Okay, here comes our fan, full speed. Can you hear that? And it's not coming out of protect, or out of soft start. Now part of that could be because this bulb is in series. Sometimes they won't come out. But the bulb did dim way down. Now the camera makes it look way brighter than it is. But it's not getting brighter, so there is no shorts. Okay, so let's now apply full power to it, and I have this fused also. There's a fuse in line with this, only at a few amps. So again, if something overloads, it'll pop the fuse in my dim bulb set. So here we go, full power. And there it is. Did you hear the fan turn off? And if you look right here at our relay, see if we can zoom in, you can see that the contacts have pulled in. So the unit is soft started and the fan died down. Now let's turn the power off, and it should drop out. And there it is. Okay, so we at least were able to get power out of this. Now what we're going to do is we're going to repeat the process. I'll do this off camera so I don't bore you to death. And I'm going to check the speaker terminals to see if there's any kind of DC sitting on the outputs. I doubt it, because I think the protect relay pulled in okay. And so hopefully that should all be good. If so, then we can be relatively safe in connecting a set of speakers just to see if this thing plays. Okay, so now I actually have the meter connected to each of the speaker terminals, and I'm just making sure they're turned on. Let's see here. Yep, speakers 1. And we're going to turn this thing on. This time we're going to turn it on full power without the dim bulb. I still have a fuse in my test socket, which it's like 4 or 5 amps. So if there's a really big power surge on the input of this transformer, it'll still pop that little fuse. So we still have some protection so we don't blow anything up. And we're going to wait and see if the protect relay comes in. And if it does, then we're going to measure our DC output voltage if there's any type of offset on the 2 speaker terminals back here. Anyway, that's what we're going to do in theory. So let's try it. So power on. All right. So soft start came in. And our protect relay just came in. So that's good. So now let's look and see what kind of DC offset we have. Not bad. So on the right channel, we have only 7 millivolts, 7/1000ths of a volt. And look at this guy here. Just under 1 millivolt. Negative. It's negative, but it doesn't matter. Just 1 millivolt. So pretty amazingly enough, there is no, even the offset's looking good on this thing. So let's now connect a set of speakers and just see if we can get any sound out of it. Okay, I have the old girl turned on. I have some speakers connected up, and let's turn up the volume and see what we get. Now I have the microphone pointed towards me. Let me rotate the microphone towards the speakers. Okay, and let's hear what we get.
The wrong resonates, which makes finding a great candidate like, well...
Okay, so as you can see, let me get the microphone back here. As you can see, it works pretty good. So this is a really loud amplifier. Of course, I will blow these little speakers across the room if I turn this thing up. But as you can see, the tuner's kind of working pretty good. And the one, I know we're not recording in stereo, but the left channel is kind of scratchy. I think all of the controls need cleaned, obviously. But the oscilloscope is nice and bright, and it's working properly. Everything's working. So I think we can move forward and know that we're probably not going to have to do a whole bunch of repairs, but it's mostly going to be a restoration. So that's good news. So let's get started and start cleaning this thing up and bringing it back to its former glory. Okay, it's another day, and it's the weekend, and on top of it, we're supposed to get a pretty major snowstorm, at least for this area. We can get snow up to knee-high, and right now it is bone dry outside. There's nothing on the roads or the cars or anything, so this is all going to hit, you know, in a short period of time. So we're kind of be snowed in a little bit till the plow trucks get going and everything. So this is a great day to just kind of sit at the bench here, get some work done. So what we're doing right now is I have the whole chassis apart. I have the bottom plate taken off, the top cover taken off. I removed the face plate and the knobs, and just kind of getting things prepared to get the different modules out and start working on them. The first thing that's going to come out is going to be the main amp module right here. There's a lot of work involved in rebuilding these because of the cooling tunnel and so forth. So they all have to come apart. Everything has to come out and be cleaned. So right now we're just marking our cables. Some of them are pretty obvious and would be difficult to get in the wrong place, but it's nice to mark them because things that look really obvious when you're looking at them together, when you have a big clump of wires and cables everywhere, can sometimes not be so obvious. I also took many pictures, and I actually keep an old cell phone around for that purpose. They make good cameras when you no longer are using them as a cell phone. So, you know, they're thin and they're easy to use, and what else do you do with an old cell phone? So lots and lots of pictures, and we're going to get these out, and as I take each module out, I'll kind of update you as we go along. Okay, so after taking out a bunch of wires and taking the 8 or so screws, about 8 screws out of the bottom, the cooling chimney cooling unit comes out, and that's it. Now I'm going to get this out, and I'm going to get the actual power supply module out. This whole thing with this board, all of this, I'm going to take that out, and those two things are the first things we're going to start with. I'm going to get those two things out, and that's going to open up this chassis a whole lot so we can actually get in there and clean and take care of all that. But also it makes these two pieces really accessible for rebuilding and cleaning and so forth. So next thing is this. Now there's 4 great big bolts on the bottom, and there's a sub chassis that holds this all together, and the whole thing's just going to come out as one big module. However, there are quite a few wires, as you can see, like up and through here and all this, all of these down in here, another bundle way down underneath here. Those will all need to be disconnected. Some of them are connectors and some of them are not, so we'll have to mark those very carefully, take lots of pictures once again, and then get that all out. Once I get the 2 modules out, we'll get the rest of the stereo off of the bench, and we're going to focus on those 2 things first, getting them restored. Then we'll return to the chassis and take care of that. So after disconnecting a bunch of wires and a lot of tangling and detangling and so forth, the power module and the amp module are both out. Believe it or not, like I said earlier, there's only 4 bolts, and they're held on by nuts on the top of this power supply. And you can see one right, I don't know if I get in shot, one here and one here, and then there's 2 on the other corners. They're pretty good sized, obviously, because of the weight of this, but really that's all that holds this in. Most of this is connected with plugs. You really only have to desolder the ground leads for the speaker wires and the blue wire that goes out to the resistors with the soft start circuit. And with the exception of that, everything else is connected through plugs. And then there are a couple little wires here in the front, these 2 orange ones and this one little ground lead that goes out to the chassis. That's it. So you have 2 wires here, 2 wires here, and 1 wire here. And this is for the power. Goes for the input power coming from the power cord. But that's it. So we're going to start taking this all down. We're going to clean it, totally take everything apart. We are going to replace the main filter caps on here. Just to make it, again, the owner wants this thing future-proofed. Doesn't want to have to, as heavy and big as this is, you don't want to have to take it apart and put it on the bench and ship it and all these things again. So even if a capacitor is good, we don't care. We're going to replace them with all new components, top quality, so that this thing can be actually used and played and enjoyed for a long time to come. So I'm going to get started on this, and we'll be back with an update shortly. So another common question I get a lot of times is, how do you actually clean these things? And the secret to cleaning this is that there really is no secret. It's all elbow grease. It's just a lot of work. I know there's videos that I've watched out there in horror as people have taken amplifiers and things and put them out in their driveways with a air hose or a pressure washer or something like that. And I can tell you, I mean, maybe in certain things that may work, but with stuff like this, tiny little components, and everything's very, very susceptible to moisture and so forth, you just can't do things like that. I go and I buy a lot of these hobby brushes. A lot of these are used for, you know, art and things like that, with real fine bristles. And I find that it's really good for loosening the dust. I go through like that. If I need some cleaning, I'll just get a shop towel, which are those little blue, I'll grab one here, hold on. Just disposable blue shop towels. I use a lot of these, and I typically don't use any crazy chemicals. I like to use either denatured or anhydrous alcohol. Sometimes I'll use a little bit of like Formula 409 cleaner or something, depending on what I'm cleaning. Maybe a little bit of WD-40 for removing some of this stuff. And then you just kind of clean it. You just polish it off and take your time. The biggest thing is taking your time. You're not in a hurry. If you're in a hurry to get this job done, you probably shouldn't start the job until you have the time to put into it, is kind of what I've found out. So, I mean, that's it. You're seeing what I'm doing right now. You brush it out. If you need a little bit of alcohol or cleaner or WD or whatever, you can see this is just denatured alcohol on a little rag, and you see how it polishes right up. And you can see there's where I didn't polish, there's where I did, and it just cleans it right off. As long as there's no pitting. Sometimes if there's pitting, I'll take a little Dremel with a little wire brush attachment, and I'll go through it and real fine, like the brass type wire brush attachment with the rotary tool, and try to clean off some of the rust or some of the corrosion. But in most cases, just wiping it like this will take a lot of crud off. And the other thing is, don't be afraid to disassemble. When you flip these around like this, and I'm working around the camera here, that's why I'm kind of fumbling a little bit. You can see all the dirt and crud that gets down in here, and I mean, it would be really hard to kind of try to get in between. So as you saw, I was taking the nuts off the back of this transformer mount, and I'm going to take this transformer and just kind of slide it out of the way. I'm going to disconnect it, move it so I can get to the plate, and just clean. That's really all I do when I clean this. Now, cleaning circuit boards, I'll go over that in this video as well a little bit and show you how I do that. It's a little different process, but similar idea. So just thought I'd share that with you to answer some of the questions that a lot of you have posted. So good stuff, keep them up. So in case you're wondering why it's so difficult when these transformers fail to repair them, you can't really rewind them as per se. Here's the bottom view of the transformer, and you can see it's rock solid. And the reason being for that is they wind that toroid transformer, and then they pot it. They put this epoxy chemical in there, and then they drop the transformer in, and then they put more on it and fill it all in. And you can see around the wires, I mean, it's completely, totally sealed in there. So you have to be extraordinarily careful when you work with these not to cut the wires. You can see they fold the chassis of it, the little outer shell, they fold it over to kind of make it so it won't cut through the wires. But you have to be very careful bending these. You don't want to cut them or anything like that. And if this transformer does burn out, like you can kind of see the outline of the windings in there, if that were to burn out, it would be difficult, if not impossible, to get that potting compound out of there in order to fix it. I mean, a lot of the older things you see in the old tube gear, they would pot these in like a wax type substance, and you can heat it up actually in a double boiler, and you can actually heat that wax hot enough to melt the wax without melting the enamel of the wires, and you can fix those sometimes. These ones, it's one and done. Once it's like that, you really can't fix it. And being that this is a special transformer specifically for these receivers, you're not just going to go out and order one on Mauser or something. So be real careful with these. And if you find one with a really good transformer like this one, it's definitely a good thing to have. So, all right, continue on with our cleaning job. Okay, so I'm starting to disconnect the capacitors and everything and get them ready for replacing and servicing. And I noticed this little skid mark here on this wire, and you can see I'm wiping it off, charred. But look down here. It's all discolored and burned right here. And when you look at the output of the capacitor here, right around the terminal, you can see where it has leaked. So I think these capacitors are really getting to the point where they're probably going to need replaced if they don't already need replaced. So kind of makes me happy that I decided to go through and do it anyway. But they would have gotten checked regardless, but I just kind of hedged my bets and ordered new ones. And these are dual capacitors, meaning that inside the one can there are actually two 7,200 microfarad capacitors rated at 100 volts each, and they share a common negative, and then the positives are here and here. So you can see there's three actual live terminals on this thing. You can't get these anymore. They're unobtainium. So what we're going to do is we're going to replace this with 4 discrete capacitors of a very similar value. Now the 7,200 microfarads are getting kind of difficult to find, but it's relatively easy to find 8,200 microfarad, which is close enough for these purposes. And with the soft start circuit in this, we're going to do a little modification to it, but that will take care of any startup current problems with a little bit of extra capacitance. Won't hurt a thing. But yeah, you can see how discolored and burned this is. So something's going on with this thing. It's probably leaking. So again, that might be one of the things that caused that channel to go bad. Because the other thing I noticed, and I was going to show you this when I started doing the service on it, but I'll show you right now. When I said that a company had serviced this before, this channel has had some transistors and some capacitors replaced, but it's strange, they only replaced a couple of the caps, and some of them they did not. And then the same thing on the side over here, a couple transistors were replaced here and a couple of capacitors, but again, not all of them. So we're just going to go through and redo all the boards, so it doesn't matter. But I thought that was kind of interesting. So must have been something that went wrong at some point in time with this amp that caused this to go bad. So good thing, that's kind of why you have to take your time and kind of look at everything closely. So let's get this out, and we'll got some parts on order, should be here in another day, and I'll show you what I do with this. Okay, so while we're waiting for some of the parts to come in for the power supply, I'm going to get started on this amplifier module. And if you look at the amplifier module here, you can see there's some screws missing. This particular board was serviced, as was this side, like we said. And you can see some of the parts they replaced, a couple of the capacitors in there. But on this side, nothing has been replaced. Now, I think the reason that we had a problem with that channel was because of this leaky capacitor. And you can see it's pretty bad. When I went to desolder the ground lug, that, you know, with all that black stuff on there, it had that really acidy fish kind of smell to it. And usually when you heat that up and you smell that smell, that is definitely capacitor electrolyte. That's what it is. So it was not corrosion. It was corrosion, but it was corrosion by a leaky capacitor. So we have bad caps, or at least one bad cap, and that's probably why this amp had to be serviced. So again, we're going to replace all that stuff. So we're going to take this off, and we're going to start with this board right here. Okay, so I have a lot of questions. How do I clean the circuit boards when they're all dirty? So I'll just go over it real quick. First of all, you just need several basic tools. I just have some denatured alcohol, some brushes that I cut the bristles down a little bit, and then I just use different cotton swabs. And most importantly, I have one of these little fiberglass scratch brushes. Now what this is for is, a lot of times you get tarnish on certain components, usually it's the Zener diodes and some of the diode leads, they'll get that black tarnish on them. This cleans it right off, and it makes it really, really easy to do. I cleaned these ones already. Let's see if one of the other boards has something on it. Let's see, right here. So if you look at this one down here, without me bumping the camera, you can kind of see the crud that's on it. If I can get some light on the subject and get the camera to quit moving. So essentially you just take this and you can just clean it right off, and you can see when it's done it's all shiny, just like that. And then you can do the other side. And these little scratch brushes, sorry I bumped the camera, these little scratch brushes do a really good job. Now, for doing the actual circuit board itself, I just take a little bit of the alcohol and get it on a little swab like that without splashing it everywhere. And then you just kind of start cleaning wherever there's dirt and dust and grime. You just kind of wipe it up, and you can see right here where you get that crud. And you can use different types of swabs. You know, these ones are a lot smaller diameter, so they work really well for getting in between, like in here, cleaning this off and getting in between the you know. Now you might say this is completely crazy, but this is what you have to do if you want it to look really good. I mean, you don't have to do this, but you know, when you're restoring it for someone else, you know, I kind of take some pride in your work. And again, this is definitely a labor of love. This is not something that's it's hard to make a profit if you do things this way. Again, I have a day job, I have a business. This is not how I make a living. I do this for relaxation and just for fun. So I could see how if you wanted to make a living out of this, though, you really wouldn't have the time to do this like this. You'd never be able to charge enough. But anyway, that's how I do it. I just go around and clean all the dust and dirt and grime off. And be careful. You want to try it in an inconspicuous area. Usually the screen printing they do on these boards is not affected by alcohol. But again, I say test a little inconspicuous area first. Like get your alcohol and go like over here where it wouldn't matter and kind of rub this ink right here. And that way if it damages this, you're not really hurting anything. You don't want to rub off the letters. But you can see this stuff here is pretty durable and resistant to the alcohol. But that's it. I'm going to get this all cleaned up. I'm going to get it recapped. I'll probably replace, I'm going to look at the schematics. I may replace some or even all of the transistors on here. I don't know. And then we'll be back. Okay, so we're pretty much finished with the peak indicator and soft start board, which is what this is, with the exception of one capacitor that I have to wait. It's on that order that I placed. All the transistors have been replaced on this. There was a replacement transistor in here, and it was a little bit underrated from the ones that were in here, and I think it was one of the damaged ones that they replaced. It was appropriate, it would work, and it did work. All of these were replaced, and I'm going to leave them because they were the correct transistors and they did a really good job soldering them in. So whoever did do the service, at least on this board, did a really good job. So I replaced these on the front end for the soft start. This one cap is all we need. So we're all cleaned up, and now we're getting ready to start the amplifier modules. And this is the one that was serviced, and right off the bat I see a couple things that's a little bit concerning. First of all, these ground leads are grounded through the rear of the board. However, if you notice, when you compare it to the original, to the other amp that's not been serviced, you can see that the screws on the original one are metal, they're silver. And if you look, these have been replaced. None of them match. And these ones are painted or enameled or anodized, and they're non-conductive, so you're not really getting a good connection from this to the other side. So we'll need to replace it with some proper, bare metal screws. And you can see this one's the original. This is the only original screw. And if you look at the threads, these screws even have different threads, I noticed. I'm not sure about those ones, but these two top ones, you can see this is kind of a machine screw, like out of a computer. Whereas this one, you can see is a coarse thread metal screw. You can see how they're all different. And they're kind of like, they kind of wallered out the screw holes here a little bit. So we're gonna put all new screws in these that match and that fit tightly and everything, because these actually are the grounds that connect the ground from this side over to this side on this other board. So we're gonna make sure that those are good. And I think we're getting a little reprieve on the snowstorm. They were calling for this great big snowstorm today, so we all stayed home. And what ended up happening was it snowed for a little bit, and then it kind of turned to rain, and now it's just this wet, slushy, nasty stuff out there, and it's not even cold enough to freeze, which kind of is a little concerning, because tonight, if the temperature drops, all that slush will turn to ice. So, long story short, it's a good day to be in here working on this. So, let's unplug this. These modules are just plugged in. And you can see this amp, let's see, yeah, it's had some work done. There's a bridge here, and I'm not sure if that's supposed to be or not. I guess it is, going from one of the transistors. And all this crusty stuff is because they put conformal coating on this. Whenever you solder on it, if you use alcohol to clean it off, which you need to, it kind of discolors that conformal coating unless you put a new new coat of it on there. And that's what that is. But not bad though. The good news is it doesn't look like the board burned up. It looks like it just had some faulty transistors that were replaced. These ones were replaced. A couple of the caps, but not all of them, as you could see. So one of the, I don't know if this is the bias or the offset pot. I can't remember. I think this is bias here. It's been replaced. This one has not. But we'll check them and see if they're good. They should be okay. I'm going to test all these, because if one of these is bad, then most likely we're going to have to replace all the transistors. And that wouldn't be a bad thing, but they're just so expensive to replace. And if they're all in good condition, then there's no need to actually touch them, because these probably all match properly and we'll just reuse them. But definitely need to clean all of this, get all the dirt off, and put new compound on them, all that good stuff. So the work goes on. So let me get started on this and we'll be back. Well, I guess surprise, surprise. This is the other amplifier, and much to my surprise, it's been serviced as well. These two transistors here and these transistors have been replaced, and even though all 8 of these transistors, 2, 4, 6, and 8 on the other ones, they're all different types of transistors, so they're kind of all mix and match smorgasbord style. So we're going to redo all the transistors on these just to make sure they're all the same type and the correct ones. These resistors, I measured them on the other side. They all measure good, but they don't all measure exactly 0.39 ohms. Some of them have drifted a little bit high. So I have some precision ones that I'm going to order in. It's important that you keep the same wattage and everything on these, because this is kind of your protection on the transistors. If a transistor has a problem, these resistors will, at 5 watts, they'll overload and open up, and you kind of want to make sure they'll still do that. So you don't want to get crazy, but it is okay to put a little more accurate ones or whatever. Won't hurt it. So the good news is the board is actually even a little bit better yet, and so we'll clean that up, and we should be good to go. So lots of work to do on this one. Okay, we have begun the arduous task of re-greasing and remounting the transistors on the heatsink. And I can only say that the closest thing I can equate it to is going to the proctologist to have a root canal. That's about how much fun this is. And I'll show you how this works here in a minute. We'll do one on camera, and you can kind of see why this design is kind of difficult to work on. So to give you an idea of why this is kind of a little bit of a time-consuming task, I've drawn this little picture to kind of show you what we're doing here. So you have the transistor on top of the heatsink. Then you have a silicon pad. Then you have the actual aluminum fins. That's kind of like the fins to the heatsink. Then you have the main heatsink underneath that. Then there's a gap. And then there's a circuit board mounting plate, like a mounting, I don't know what you'd call it. Then you have the actual circuit board. The circuit board has the holes, and then inside those holes, instead of the pins being directly soldered to the circuit board, you have these little cylinders, little eyelets. The eyelets push in from the top of the circuit board and go down over the pins. Sorry. And the eyelets solder to the pins, and the top of the eyelet solders to the circuit board. If you take it out and leave the eyelets in, you really can't fish these pins back in, because those holes are just barely the size of the pins. So you really have to remove these eyelets. You have to clean the board. It is a big mess. And then you have to kind of fiddle everything all back together. So you'll see when we do this one what I'm talking about. So the first thing we're going to do this one. And you can use the desoldering iron, and it will work. But really, you really don't need it for this. I found it's a little bit easier just to use a pump. And the longer you dwell on this pad, the bigger the chance that the pad's going to lift off the board. So you really can't be on there for a very long time. So the first thing you do is you heat it up. Sorry about the smoke. And you do that. And that pulls it right out. Now we lucked out on this particular one because the soldering pump actually pulled the eyelet right out of the circuit board, which was really nice. In some instances it stays in there, and then you have to heat it a second time once you get the solder out of the way, and you got to kind of get a little pair of wire cutters and kind of use them not to cut in, but actually to reach underneath this little lip right in here and lift it up off. Once you get these two little eyelets out, you have to save them because you're going to be reusing them. Let's do the other one, and we'll see if this one comes out as well. If not, we'll have to lift it. Let me get a extractor here so we don't have to have smoke in the lens here. Okay, we'll see if this works. I have the fume extractor on, and I actually connected it to my Variac to slow it down so it's not so noisy, so you can actually hear. We'll see if there's enough airflow to actually keep it quiet and yet still be able to use it. So let's heat up this other one, and we'll see. Now, of course, you have to take your solder pump apart to get the little eyelet out if it sucks it up in there. You can also use desoldering wick, but you use up an awful lot of it for this because it's a pretty big blob of solder. So let's heat this up. And now that one came up a little bit but didn't come all the way out. So what we're going to do now is I'm going to turn up the speed of my fan so it's a little bit better. There. And we're going to just heat this up very quickly and take it off. The less dwell time, the better. So now we have that out. And we're going to take these little eyelets and just kind of sit them off to the side in a safe place. Put them in a little container or something so you don't lose them. Actually, I'll do that right now. And now we're ready to actually remove this from the other side. So give me a second to reposition. Okay, so I stuck some long screws in here just to kind of act as some little feet so you're not bending these pins. Then you can flip this thing over just like that, and then we can just take the transistor right out. So we just loosen these, and these screws on here are barely even touching. So really the only thing that was holding the transistors to the heatsink was the solder and the circuit board itself. You don't want to crush these till they strip, but you do want them to be snug. They do have lock washers to apply some pressure, and that pressure, it helps to couple the transistor to the heatsink. I get a lot of questions about these things, the TO3 transistors, and I think there's a lot of confusion with people who haven't worked with them in the past. But just so you understand, the way these work, as we know, transistors have three elements: base, emitter, and collector. And if you look on these transistors, there are only 2 pins. So we have the base and emitter, but where is the collector connected? Well, actually the collector on this transistor is the case itself. Now, another thing people get confused about is how this thing can dissipate heat down there when this is the transistor. Well, this is not the transistor up here. This is actually this top part. If you see, there's a little crimped, like a little seam around there that's kind of welded on. This is just a cover. The transistor is actually inside here, and it is actually physically mounted. The substrate is mounted to this oval-shaped plate on the bottom. So it actually, this whole bottom metal section is thermally connected to the actual silicon transistor element itself. So when the transistor is very tiny. As a matter of fact, if we were to take this cover off, we'll do this someday, you'd see that the transistor inside there is really not much bigger than a little tiny signal transistor that we use. But because of its massive amount of heat dissipation, the transistor can handle a lot more power. And there's other things involved as well, obviously, but that's how these work. So whenever you couple this plate here to the heatsink, you are actually thermally coupling it. The other thing is, people ask, why do you need an insulating pad? Well, because this is an active element, unless the collector is at ground potential, which is your chassis, if it's floating anywhere above or below ground potential, then if you electrically connect this to the chassis, you're shorting that circuit out. So this pad insulates this element, the collector, from ground. And the screws, when you put a screw through this transistor, they electrically touch this case, which is connected to the collector. And on the opposite side, where they screw into, the screws actually act as a conductor. If you look here, we're going to remove this now. You can see there's these little tubes, these little sleeves. And these are either plastic or ceramic. And they're non-conductive. So that prevents this screw from actually touching the heatsink. On the opposite side, the threads that you screw into, which are right here, are actually soldered to the underside of the board. So when you tighten these down, this is a double-sided circuit board, sometimes the threads are on the top of the board. You're actually making contact between the case of the transistor, which is collector, and the circuit board. That's how it works. So we are electrically connected up here, but we are electrically insulated from the heatsink, but we are thermally connected to the heatsink. Okay? We want the heat to get to the heatsink, but we don't want any of the electricity to get there. I know this is really boring for some of you who work with this stuff all the time, but I have literally had, I would say, dozens of comments on any video. Anytime I do a video with these transistors, I seem to get all these confusing questions trying to understand how these work. That is how they work. That's how a TO3 transistor works. And even the TO220, you know, the little square transistors with heat sinks, same thing. That's why they put a thermal pad. The pad helps to couple the heat from the transistor to the heatsink better than just metal-to-metal contact, and it electrically isolates that voltage from the chassis. Hope that helps you guys out. All right, let's continue with our little job here. Okay, the next thing we want to do is clean the old heatsink compound. Now, some of the older 1970s vintage used a clear heatsink compound that you can't really, it's not white. A lot of people are used to seeing that white silicon paste. This actually does have some, but if you notice, wherever it's really shiny, there's no heatsink compound at all. And especially the big place you want to get your heatsink compound is right here in between the pins, because right underneath this on the opposite side is the actual transistor. This is where the most heat is going to radiate into first. So you want to get some paste on there. If you notice, there's almost nothing on here at all. So they barely even, most of it's dried off or evaporated, gone, whatever. So you're not getting very good thermal coupling between the transistor and the heatsink. And that's what causes transistors to fail early, is when they can't dissipate their heat properly and they run at a higher temperature. Just like capacitors, when you run them at high temperatures for long periods of time, they will begin to fail. So we want to prevent that. So we're going to take this old mica pad. This is mica. And again, it is a very good conductor of heat and a very poor conductor of electricity. We're going to remove that. And then we're going to clean this little sub heat sink, we'll call it. And I'm just going to brush it off real good. Clean all the dust and dirt. If it's really, really cruddy, you may have to run it under some water or something and clean it off. And then we're going to clean all the old grease. And if you notice, there is no grease, hardly at all. So you really weren't, and down here, there's a little tiny bit, and you can see it's really pretty badly dried and it's turning yellow. So this is a maintenance thing that needs to be done whenever you're restoring an old amplifier, especially something that's 30 years old. That grease, the grease they had at the time wasn't quite as good as the stuff we have today. And even with that, it's just old and it's going to dry out. Okay, we're going to be reusing the original transistors on this one. So, and I felt it would be okay. I mean, the owner doesn't want to get too terribly much money in it. You know, he's going to put a lot of money in this to begin with, in all the parts. But you know, when you add 16 big power transistors, good quality ones, you're really getting into a lot more money. So these transistors are very good quality transistors. For their time, they were some of the biggest ones available. They are in excellent condition. They have the original Marantz branding on them, which is really cool. And when we tested the amp, even before restoration, we checked for DC offset, and you notice there was none. I mean, it was just tiny millivolts. So it tells me that none of these transistors seem to be leaking or having any problems like that. And just to be double sure, this isn't an end-all test like a big curve tracer would do under load, but these actually do a pretty good job. And I have it connected to the computer, which I'm not going to move the camera around, but just give them each a quick test just to make sure they're good. And I can scroll over here, but I can see everything on my screen. Again, they're all kind of tracking pretty close to one another. So yeah, these are just fine, but you want to kind of test them if you're going to reuse them, just to make sure, just in case you run into one that might be shorted or leaky or something. Okay, the next thing we're going to do is we are going to use what's called a sill pad. And there are different grades and versions of these, but sill pads are actually pretty good for this particular application. If you notice, we're making a sandwich out of the heatsink. You're going to have the transistor, you're going to have one thermal isolator, then you're going to have more coupling compound, and then you're going to have the main heatsink. So really, that becomes a big mess. So instead of using a mica pad, I'm going to use a sill pad for this particular one, and then I'm going to use really high quality grease on the bottom. Now the other thing you have to remember about heatsink grease is there is conductive and non-conductive heatsink grease. Please look at my video on mounting a TO3 transistor. I get into that a little bit. You want to just make sure that you're using the correct heatsink grease on this. You want non-conductive, obviously. So we're going to get that mounted up. I'll put some grease on this thing right now here. And again, you want it to be I always start in the middle and kind of work my way out. And you just paint it on. No big deal. You don't want too much, but you don't want too little. You just want a nice thin coat. And when it squishes down, the idea is it just kind of fills in all those micro scratches and so forth. And that's really all you need. And that's it. So we're going to drop this in here, which can be kind of fumbly with these little heat sinks. Like that. And then get this the right orientation. And we drop it down in. And we put our screws back in. And we solder it back together. So once we get this flipped over, I'll be right back. Okay, to put these little eyelets back in, oftentimes there will be residual solder both inside the eyelet and on the pin. And since this is just barely the size of the pin, it won't fit over there, and you really can't clean it out properly. So the best thing to do is get a little pair of needle nose, get your soldering iron, get it positioned over the pin, just like this. Shaky hands, too much coffee. And you just heat it up, and it pushes right down on like that. Once you get it seated, then you can come in with your solder and fill it all back in. And I think I'm going to clean this off because there's a lot of flux on there. So use some of my daughter's makeup swabs. Hey, they work good. You can get these at the drugstore and pharmacy, really inexpensive, and they work really well because they actually have like cotton. They're not the cotton strands like a Q-tip type thing, so they don't leave as many of those little hairs. They work really well. So solder it back on. And really, that's all there is to it. And the idea is don't stay on there so long that you lift the pad. And that's pretty much it. That's all there is to it. So we're going to just do this for all the rest of them. And I'm going to end this video right here now, part 1, and get it posted. Because now once I get this all done, I'm kind of on a little bit of a holding pattern until tomorrow, where a whole shipment full of all the parts that I ordered. I have a lot of stuff in stock, but there were quite a few special parts for this amp because of how big it is and some of the high voltages that it uses. I had to order. The relays are a little bit different than some of the ones I keep. So we'll end this video right here. We'll pick it back up on the other side here when I get some parts in, and we'll continue on. So I hope you enjoyed this first part, and I hope you got a few things out of it. And if nothing else, I just hope you had a little bit of sleep time here. So anyway, thanks again for watching. Thank you for everything, all the wonderful comments and the donations and all that sort of thing. And I wish you all peace, joy, happiness, and good health in your lives. And we'll see you soon as we get some parts.